This is your video for 7-1. Our objective today is to evaluate and simplify expressions containing zero and integer exponents. You know how to evaluate positive exponents. What if an exponent is 0 or a negative? What do you think the value of 5 to the 0 or 5 to the negative 2 is? Let's use a table to determine the answer. You do not have to write anything on this slide down. So up here we have the powers. We have 5 to the 5th power. We know that that is 5 times 5 times 5 times 5 times 5, which gives us 3,125. Then we have 5 to the 4th power, which is 5 times 5 times 5 times 5, 4 times, and it's 625. 5 to the 3rd power is 5 times 5 times 5, which is 125. 5 squared, or 5 to the 2nd power, is just 5 times 5, which is 25. And 5 to the 1st power is just 5. If you notice what's happening here, each time with the value, if I take that value and divide by 5, I get the next value. If I take that value and divide by 5, I get the next one, and so on and so forth. So let's look at 5 to the 0. If this trend continues, then I would say 5 divided by 5, and 5 divided by 5 is 1. So 5 to the 0 power is 1. If I take and divide 1 by 5, I get 1 over 5. And if I continue that again, 5 to the negative 2, so I say 1/5 divided by 5, and that's 1 over 25. Notice that 5 to the 2nd power is 25, and 5 to the negative 2 power is 1 over 25. 5 to the 1st power is 5, and 5 to the negative 1st power is 1 over 5. And it says answers should be in fraction form, no decimals. So again, 5 to the 0 is 1, 5 to the negative 1 is 1 over 5, and 5 to the negative 2 is 1 over 25, or 1 over 5 squared. Here's our first exponent property that we're going to look at. We're going to take these 3 at a time. There are 9 altogether. So today we're going to look at the first 3. On your worksheet, you need to go ahead and fill that in as we go. The first power, or the first property, says that a to the 0 equals 1. That's the 0 exponent. Any non-zero number raised to the 0 power is 1. So no matter what it is, if it gets raised to the 0 power, it turns into a 1. If it's x to the 0, it's 1. If it's 1,225 to the 0, it's still 1.
Pause for just a moment. Let me make sure they've got this in the right spot. All right, just so we're all on the same page, when she said your worksheet, that means this worksheet right here. So at this point in time, you should have written here that any non-zero number raised to the 0 power is 1. So you should fill that blank in with the 0 power is 1. And on this PowerPoint, for the next 3 examples, you're going to be filling in your first 3 properties here, and you're going to put the examples that we give you over here in just a minute.
Alright, so let's look at some examples, and again you need to be filling these in on your worksheet under the property number 1 under examples. And it says negative 2 to the 0 power is 1. 3 to the 0 power is 1. 3 over 7 to the 0 power is 1. Again, anything to the 0 power is 1. Variables are the same way. X to the 0 is 1. M times n to the 0 power, as long as both the m and the n are being taken to the 0 power, is 1. R over S to the 0 power is, again, 1. This is probably one of everybody's favorite properties because, again, all we have to look and see is that it's to the 0 power and it is equal to just 1.
All 6 of these examples, the 3 number examples and the 3 variable examples, should be written in your example box under the property number 1 on your worksheet before you continue.
Zero to 0 is undefined, and you can actually type this into your calculator and see what happens. It's going to tell you that it's undefined. It says you'll learn more about why this is undefined as we continue to learn the exponent properties. This is our second exponent property, and it says a to the negative n equals 1 over a to the n. And we like to say that exponents don't like to be negative. They like to be happy and positive. So here, the negative, the exponent is negative, and it doesn't want to be negative. It wants to be happy and positive. So it's not happy being on the top, so we're going to put it on the bottom. Whenever we put the a to the n on the bottom, the n turns to a positive happy n. And there's nothing on top, so we go ahead and put a 1 there. In words, any non-zero number raised to a negative exponent is equal to the reciprocal of the fraction with a positive exponent. And reciprocal just, again, means flip the fraction.
So on your worksheet that you're taking notes on, you should have just positive exponent, filling in that blank there. Positive exponent is all you have to use to fill in that blank there.
All right, let's look at some number examples. The first one is 3 to the negative 2, and that's equal to 1 over 3 to the second power. And then 3 to the second power is 9, so 1 over 9. 2 to the negative 4th power is 1 over 2 to the 4th, and then 2 to the 4th is 16, so it's 1 over 16. Let's look at some variable examples. Y to the negative 4th power is equal to 1 over y to the 4th power. X to the negative 2 power is equal to 1 over x to the second power, or x squared. Take a minute, make sure you have all of the number and variable examples written in the box underneath the second exponent property.
I'm going to show you what that should look like. All right, this is what it should look like. You should have positive exponent written here, and then you should have your examples in both numbers and variables written here.
And it says 0 to the negative n would equal 1 over 0 to the n. It says 0 raised to any power would be 0. The denominator cannot be 0. So that's why it says over here that a is not allowed to be 0. Our third exponent property says that 1 over a to the negative n power is equal to a to the n power. And again, exponents do not like to be negative. So here the negative n is unhappy on the bottom, so we're going to flip it to the top so that the n exponent can be a positive happy exponent. Negative exponent. Any denominator raised to a negative exponent is equal to the reciprocal of the fraction with a positive exponent. Again, it's basically the opposite of the last one. The last one, the exponent was negative on top, so we flipped it to the bottom to make it positive. Here, the exponent is negative. It's on the bottom of our fraction, so we're going to flip it back over to the top to make that exponent positive. Let's look at some number examples. 1 over 2 to the negative 3 is just 2 to the third, which is 8. 1 over 4 to the negative 2 power is just 4 to the second power, which is 16. Some variable examples, 1 over x to the negative 5th is just x to the positive 5th. And 1 over m to the negative second power is just m to the second power, positive second power. Again, make sure you have all the number and variable examples written on your worksheet.
All right, so far this is exactly what your worksheet should look like for today, and you're not going to put anything else on this worksheet. So from this point forward, you need to add a clean sheet of paper, and your notes are going to be on paper from here on out. Make sure and bring this worksheet with you to class tomorrow. That way you have it to look at while you do your assignment. So it says 1 cup is equal to is 2 to the negative 4th gallons. Simplify the exponent expression. So that's what we're going to write for number 1 is 2 to the negative 4 power. And again, we're going to look over here. I've got the properties listed over here to the side in green. You do not have to write those on your paper. You already have them written in your worksheet. But we're looking at this second property right here that says if the negative exponent is on the top, we're going to flip it over to the bottom. So that's what we're going to do here. The 4 right here is negative and unhappy, and we want it to be positive and happy. So we're going to flip it to the bottom. So 2 to the 4th power is going to be on the bottom so that that 4 can be happy and positive. There's nothing on the top, so we're going to put a 1. So 1 over 2 to the 4th. And then 2 to the 4th power is 2 times 2 times 2 times 2, which is 1 over 16.
Make sure you have this written down before you move on.
All right, it says a sandfly may have a wingspan of up to 5 to the negative 3 m for meters. Simplify the exponent expression. Let's look at this problem. You have number 2 is 5 to the negative 3. We're going to look at this one on paper. All right, so I've written here 5 to the negative 3, and I want you to take a minute, look at the property. You have a to the negative n equals 1 over a to the n. I want you to see if you can figure out what this one's going to be on your own before you move forward. All right, hopefully you've tried to solve it, and now I'm going to show you what it should be. Because my exponent is negative and it has to be happy and positive, I have to flip it. So because this is an understood 5 over 1, I'm going to flip my fraction and say 1 over 5 to the positive 3. My exponent becomes positive and happy now that I moved it to the other side of the fraction. I can further simplify that by saying 5 times 5 times 5, which gives me 1 over 125. So that should be my final answer for this one.
All right, this is number 3. It says 7 to the 0 power. Again, make sure you have that written down. This one's super, super easy because, again, anything to the 0 power equals 1. So 7 to the 0 is just equal to 1. Take a minute, make sure you have it written down before you move on.
All right, we're going to have you try number 4 on your own as well. You should have 2 over m to the 0 power. 2 over m to the 0 power. See if you can figure out what the answer to this would be. You're using the property a to the 0 equals 1 because anything to the 0 power equals 1. Hopefully you've taken a moment to try to figure that out. M to the 0 is going to be 1. We don't even have to know what m is because we know that no matter what, as long as it's not 0, anything to the 0 power equals 1. So it's the same thing as saying 2 over 1. And we also know that 2 over 1 is the exact same thing as saying 2. So 2 over m to the 0 power is equal to 2. So that's your answer.
All right, this is number 5. It says 1 over 10 to the negative 3rd power. So again, this time we're going to be using that third exponent property that says 1 over a to the negative n equals a to the n. The negative 3 exponent is negative and unhappy on the bottom, so we're going to flip that to the top so that that negative 3 can become a positive happy 3. So it becomes just 10 to the positive 3 power, and then 10 to the 3rd is 10 times 10 times 10, which is 1,000. So that's your answer to that one. Make sure you have it written down before you move on.
All right, take a look at number 6. I've written mine on 2 lines. You don't have to write yours on 2 lines, but I just wanted to make sure that it was big enough for you to see it. So if you need to write it on 2 lines, that's fine, but if you don't, then don't feel like you're required to. We're looking at property number 3 here, so 1 over a to the negative n equals a to the positive n. I want you to try to do this one on your own real quick. See if you can figure it out. If you can't, then go ahead and play the video on and see what the correct answer is. I'm going to break this one down step by step. So I have 1 over negative 3 to the negative 2. The first thing I'm going to do is make my exponent happy and positive, so I'm going to flip it up to the top of the fraction. So I'm going to say it's the same thing as having negative 3 to the positive 2. And again, that's understood as over 1, so that's the exact same thing as just having negative 3 to the positive 2, because that one is understood. Now, negative 3 to the positive 2 is the same thing as saying negative 3 times negative 3. Negative 3 times negative 3 equals positive 9. So my answer there is positive 9.
All right, go ahead and write down number 7. Number 7 and number 8 are going to be very similar to each other. The difference is on number 7, there's parentheses around that -5. So we're going to look at what happens whenever there's parentheses around the -5. So it's -5 to the -4th power. And again, that exponent is unhappy and negative. We want to make it happy and positive. So it's on the top, so we're going to flip it over to the bottom. And we're using property number 2. And at the bottom it says caution, in parentheses -5 to the -4. The base is negative because the negative sign is inside the parentheses. So we're going to say 1 over -5 to the +4 power. So -5 to the 4th power is -5 times -5 times -5 times -5. And that gives us 1 over 625. Take a minute, make sure you have this copied down before you move on to the next example. All right, this is number 8. Go ahead and write it down. It says -5 to the -4th power. Notice it looks a lot like number 7. The difference is here there are no parentheses around the -5. And that's going to change our answer here. We're still using that second property because we still want to make that -4 into a positive happy 4. And it says, in this case, -5 to the -4, the base 5 is positive because the negative sign is not included in the parentheses. So we're going to keep that negative out in front, and then we're just going to say 1 over 5 to the 4th power. Again, the negative is staying out front and not going with the 5 because there's not parentheses around the negative. So the negative is not being taken to the 4th power.
So you see it out here.
Then we're going to finish up by just saying 5 to the 4th power is 5 times 5 times 5 times 5. And so again, we leave that negative out in front and we say that this is a -1 over 625. So there's a huge difference if you have parentheses around the negative and when you don't. When you have a negative, or when you have parentheses around the negative gets to go with the number. If there are no parentheses, then the negative has to stay out front and does not get to go with the number. Take a minute, make sure you have this copied down before you move on. Go ahead and write down number 9, 7w to the -4th power. And in this case, again, we're going to use property number 2, which says that that exponent doesn't like to be negative and unhappy, and it is, and it's on the top, so we're going to put it on the bottom. However, we have to be careful with this one because we have that 7 in front. That 7 is not being taken to the -4th power. So we're going to write this as 7 times w to the -4th power. It says, caution, in 7w to the -4th power, the base is w. The 7 is not included in the base. So again, the 7 is not being taken to the -4th power, only the w. So we're going to write this as 7 times 1 over w to the 4th, which is going to give us 7 over w to the +4. Again, the 7 is not going to go to the bottom because it's not being taken to a negative power here. Only the w is being taken to a negative power, so it's the only thing that gets moved to the bottom. Take a minute, make sure you have it copied down.
Okay, we're going to look at number 10. Number 10 it has some similarities to the last one you looked at. If you want to go ahead and try number 10 on your own, you're welcome to do so. It is -5 over k to the -2, and the property again that we're looking at is 1 over a to the -n equals a to the n. All right. Just like in that last problem where the negative exponent only applied to the w and not to the 7, this negative exponent only applies to the k. It does not apply to the -5. So we're going to bring the k up to be with the -5. So we have -5, and then we bring up our k and make our 2 happy and positive. Don't get confused there and think that you're supposed to flip the fraction. You only bring whatever has the negative exponent to the other side of the fraction. So our final answer there is simply -5k squared. Make sure that you have that copied down before you move on.
right, go ahead and write down number 11. It's r to the negative third power over 7. Here we're using property number 2. And again, r3 is taken to the negative power, and it's unhappy. It's an exponent that's unhappy. So r to the negative 3. We want to make that negative 3 into a positive happy 3. It's unhappy on the top, so we're going to flip it to the bottom. Now it says, caution, do not move the 7 in the numerator. Or do not move the 7 to the numerator. Here, the 7 is not being taken to the negative power, so he's just fine and happy at the bottom. So we're going to take the r to the third and just move it down with the 7. Again, you're not going to move the 7 to the top. The 7 is perfectly happy where he's at. Okay, so there is nothing left on the top, so we just make sure and put a 1. So 1 over 7 r to the third power. Go ahead, take a minute, make sure you have it written down before you move on.
Sorry, I meant to pause before I did that. I hope that didn't confuse you. I want you to try this one on your own. It's very similar to the ones that we've just done, the last few examples that you've seen. You have g to the fourth over h to the negative 6, and again, your property is 1 over a to the negative n equals a to the n. Just be mindful that the negative exponent only affects the variable that it actually goes with. Hopefully you've paused the video and tried this on your own. Let's go ahead and look at the answer. Your h is the only thing in your problem that has a negative exponent, so it's going to be moved to the top to be with your g to the fourth. So you have g to the fourth, h to the 6 as your final answer. Go ahead and make sure that you get that copied down before you move on.
All right, go ahead and write down number 13. Okay, number 13 looks complicated. We're going to take it a step at a time. Okay, go ahead right now and just make sure you have it copied down. It's a to the 0, b to the negative 2 power over c to the negative 3 power, and d to the 6 power. Again, we're going to work this one step at a time.
Hold on. Got it.
First thing we're going to look at is this a to the 0 power. We know that anything to the 0 power is a 1, so we're going to go ahead and turn that into a 1. And it's not a to the 1, it's just a 1. The a completely disappears here. Then we're going to look for our negative exponents. The first one I see is this b to the negative 2 power. The b to the negative 2 is unhappy on the top, so we're going to flip it to the bottom so that that 2 can be a positive happy 2. So it's going to get put to the bottom. My 1's going to stay on top, and I have b to the second, c to the negative third, d to the 6th. I'm not finished because I still have a negative exponent. I have c to the negative third power. Since it's negative, it's unhappy, so it's unhappy on the bottom, so we need to move it to the top so that it can be happy and positive. So we're going to move the c to the third to the top, and I have 1 c to the third over b to the second, d to the 6th. And you could actually go ahead, you don't actually need that 1 anymore since you have something else on top. So you could write that as c to the third over b to the second, d to the 6th. Take a minute, make sure you have all of that written down.
All right, so at this point you should be able to evaluate and simplify expressions containing 0 and integer exponents, and this is the end of your video for the day. Thank you for watching. Don't forget to bring your notes and your worksheet to class tomorrow.